Hello everyone, welcome back to lecture series on aerospace propulsion. In the previous lecture, we were discussing about the uh, what is combustion chamber cooling. Why do we need the combustion chamber cooling? What are the different types of method we are using for the combustion chamber cooling? How does each and every methods varies, and how do we measure the effectiveness of a particular cooling technique? And then we have discussed about the what are the basic requirements a particular fuel has to satisfy if at all it is going to be used for the aerospace application or aviation application and all we have discussed. Okay, so in today's lecture, what we are going to start is that we are going to start entirely a new chapter, okay, which is a compressor. Okay, so you see, when we have discussed about the gas turbine, we have seen the different component of a gas turbine engine. It is starting off with an intake or a diffuser. After that, we have the compressor, combustion chamber, turbine, and a nozzle. So we have already completed the static parts like intake, combustion chamber, nozzle. Now we are going to start or discuss about the rotating component, that is turbo machinery of a gas turbine engine. Okay, you see the turbo machinery is very important component for the operation of your any gas turbine engine. Okay, without this turbo machinery, you can't call them as a gas turbine, or the gas generator requires this turbo machinery. So in this chapter, we are going to discuss about these different types of turbo machinery and how do they operate and what is the function of this each and individual turbo machinery. Okay, so what we are going to see in this structure is that we are going to see the different classification or different types of your compressor, and in that we are going to especially we are going to discuss about how does an axial flow compressor is able to increase the pressure or basic operation of our axial flow compressor we are going to discuss. Okay, so before going to compressor, let us discuss about what is this turbo machine or what type of equipment we call them as the turbo machine. Okay, basically these turbo machine names come from the Latin origin. What is the meaning of this turbo is that basically a device or anything which rotates or spins, we call it as the turbo. So basically if you take a turbo machine, which is a compressor or turbine or your fan, they are a rotating components. So all of them we call it as the turbo machines. Okay, so this turbo machine we usually call it as the rotor dynamic devices in which there is an energy transfer happens. This energy transfer may be from your fluid to your machine or your machine to your fluid. So based on that we are having the classification. Let's say if I'm going to take a compressor or fan, here what is happening? In the compressor, the energy of your machine, that is rotating or rotor component, that is mechanical energy, is transferred into fluid energy. Basically, we are increasing the pressure. Okay, in the compressor. Let's say if I'm going to take a fan, here also the energy transfer is occurring from your machine to fluid, that is mechanical energy is transferred into fluid energy. But what form? In the compressor, we are increasing the pressure, whereas in the fan, we increase the velocity. Basically, your compressor and fan, they comes under the same category of your rotodynamic device, but only difference is that the conversion of your mechanical energy into what form of fluid energy. So in case of your compressor, we convert mechanical energy into pressure, whereas in the fan, we convert mechanical energy into velocity. Okay, if I'm going to take a turbine, basically this is also another turbo machine where the whatever happens in the compressor happens in the reverse manner in case of your turbine. Basically, in the turbine, your fluid energy is converted into mechanical energy. Okay, that is your fluid will have the high pressure and high temperature. This high pressure and high temperature will be converted into kinetic energy. That kinetic energy of your fluid will be converted into thermal energy when they are passing through the rotor component of your turbine. Okay, so now we are going to first start with the compressor, because in the gas turbine we are not using fan. We are using fan in the turbofan engine, but let us discuss the fan later. First, we are going to talk about the the main component of your engine, that is a compressor. Okay, so first of all, before studying about what are the different types of compressor and how does a compressor is able to increase the pressure, I should know why first of all we need a compressor in a gas turbine engine. Okay, you know, your gas turbine is basically what? It is the control volume. Since your volume is fixed. Okay, we have a thrust equation. F is equal to m dot A into 1 plus F UE minus UA plus A into PE minus PE. Okay, so your momentum thrust part, pressure thrust part. So whatever it is, basically it is the product of your mass flow. So the purpose of our gas turbine in the aircraft is it is to produce the thrust force. Okay, so your thrust force is related to how much amount of air mass is passing through your engine. Okay, and how much velocity difference you are creating. The velocity difference is going to depend on how much temperature rise you are creating. The mass flow rate depends on your compressor. Okay, see your compressor, let's say in the static condition, when I'm going to start my compressor, what is going to happen? It is going to create the suction. By creating the suction, it is sucking huge amount of airflow from your outside and compressing it. Basically, it is reducing the volume of your fluid and it is increasing the pressure. Okay, if I don't have the compressor, what is going to happen? Your flow will just simply enter and there won't be much of that. Is the volume of fluid passing through your combustion, the engine will be limited if you don't have the compressor. But the volume or mass flow rate is very, very important because they are directly proportional to how much amount of thrust we are producing. Okay, so the compressor in your gas turbine is very, very important component. Was for what purpose is that? It is having a two legs of primary function and a secondary function. So what is the primary function of an compressor is that it should supply the required amount of mass flow of air with the required pressure. Okay, there is a certain requirement for my combustion chamber. You have seen, right? If let's say if I don't have the compressor, if the directly air is coming inside here, directly going through your combustion chamber, means the amount of air enters inside your combustion chamber will be limited. Okay, so what will happen? The amount of air required is not sufficient, means your combustion process will happen, but if you don't have sufficient air for the cooling purpose, your combustion chamber is going to fail. So there is a certain requirement needed by your combustion chamber, that is your incoming air should possess certain amount of temperature and certain amount of pressure. That certain amount of temperature and pressure is being delivered by your compressor, that is its primary function. And secondary function is that it should provide a source of the bleed air. Okay, so bleed air in sense the secondary function of your compressor is to supply the. It should act as a source for the bleed air. So, what is the purpose of your bleed air engine? We have so many applications. Let's say first is your cabin pressurization. Okay, you see, when you in the we are human beings. Okay, we are comfortable with living in this sea level pressure. Okay, now let's say either if you are going inside the deep sea, what is happening? The pressure is increasing, you feel very uncomfortable. At the same time, when you go to a higher altitude, what is happening? Your pressure is getting reduced. The pressure is getting reduced means what will happen? If we are not going to control that pressure, what is going to happen? Because of the high pressure inside, you will start bleeding. Because we human beings are comfortable with the sea level condition. When you go to very, very high altitude, usually where is your commercial aircraft fly? In the 30,000 feet, around 11 to 12 kilometer altitude. In that 11 to 12 kilometer altitude, your pressure is very, very high, even less than half of your atmospheric pressure. So what will happen? You will feel very, very uncomfortable. So what we'll do is that we will pressurize the cabin so that the pressure inside your cabin will be similar to that of your atmospheric, that is sea level condition, so that we won't feel any uncomfort. So from where we are taking, or from how do we pressurize is that basically we take the high pressure air from your compressor, this bleed air from your compressor, and we use that air to pressurize our cabin, either for heating or cooling purpose. You see, at that 12 kilometer altitude, your outside temperature is minus 50 Kelvin. So minus 50 means very, very low temperature, right? So we have to either provide the heating or cooling, that depends. Okay. And another application of your bleeder is that de-icing and anti-icing equipment. So de-icing in sense, you see, when your aircraft is flying at that high altitude, okay, if there is a too much amount of moisture content present in the air, when they are going to move over your aircraft surface, what is going to happen? It is going to create the ice. Once your ice forms, what is going to happen? It is going to change the contour of your entire wing surface. Let's say take a wing surface, which is going to affect its aerodynamic performance. So we have to de-ice that. That is, we have to melt that ice accumulated. So for that, what we will do? We will send this high pressure air from your compressor. Basically, it will have a high temperature also, bit of high temperature than your surrounding atmospheric air, which will use that for the cooling purpose. And another one is an anti-icing equipment. Anti-icing equipments, basically, they are the equipment which will prevent the formation of icing itself. How we use that? Once again, by continuously blowing the hot air from your compressor, we will be able to prevent the formation of ice. Another one is the pneumatic starting of your engine. Okay, so pneumatic starting of your engine in sense, the high pressure air will be used for the starting of your engine. So these are all the secondary purpose of your bleed air from your compressor. Another important application of your bleed air is that the cooling of your turbine blades. Okay, see, the combustion chamber, it's a static component. Okay, so we provide certain amount of cooling. Even with the cooling, the air enters inside the turbine will have a temperature of around 1300 to 1400 Kelvin. So in this 1300, 1400 Kelvin, when they are entering in the rotating component, it's not a stationary component. Since it is rotating, you will have a huge mechanical stress already. When the high temperature gas enters, what will happen? It is going to increase the stress on your material once more. So if I'm going to withstand this high temperature, obviously I should provide the cooling. How do I provide the cooling? Is that the bleed air from your compressor will be passed inside the turbine blades, which is going to act as a cooler. So these are all the purpose of purpose of your bleed air. So basically, what is the source of your bleed air? It is from your high pressure stages of your compressor. So this is the function of your compressor, not only for the combustion purpose. There is having a multiple secondary application. As such, the compressor in your aircraft engine is what to say, very, very important component. Okay. Now we are going to see the what is the classification of your compressor. So compressor means, as your name suggests, is going to compress your air. Meaning is that it is going to increase the pressure. How it is increase the pressure now we will see. Before that, we will see what are the classification of your compressor. When we take a compressor, we have a major category. One is a intermittent flow compressor, another is the continuous flow compressor. Intermittent flow means the flow through your compressor will not be a continuous one. It's kind of like a pulse. Okay. So whereas in your continuous flow, your airflow will be continued to pass through. So best example for your intermittent flow compressor is that your reciprocating compressor. You might have seen this reciprocating compressor in the fuel stations where to pressurize your wheels, automobile wheels, we use that what to say, intermittent flow compressor. Basically, that is a reciprocating compressor. Okay. Whereas in your continuous flow, we have two types. One is a dynamic, another one is the ejector. What is the dynamic means? Basically, they are going to increase the pressure by using a rotating component. Whereas in the ejector, we won't, we will just kind of like a similar to a nozzle, okay, where your pressure changes will happen. Okay, so ejector is, we don't have any rotating component, whereas in the dynamic compressor, we'll have the rotating component. Okay. The rotating component, once again, the dynamic compressor, we have three cases. One is a radial flow compressor, mixed flow compressor, and another one is the axial flow compressor. So what is this radial flow compressor? In sense, the flow entry will be in the axial direction, while leaving, they will leave in the perpendicular direction. What is the radial flow means? If the entry and the leaving of your flow will have a 90-degree changes, that type of dynamic compressor we call it as the radial flow compressor. Best example for a radial flow compressor is the centrifugal compressor. The centrifugal compressor was the one which was used mostly in the earlier days gas turbines. Okay. Next one is the axial flow compressor. It's axial flow compressor in sense your flow entry and exit will be in the axial direction. Basically, your flow will be moving parallel to rotation of your shaft when they are exiting, whereas in the centrifugal compressor, when they are exiting, they will be perpendicular to rotation of your shaft. Okay, and mixed flow. What is this mixed flow compressor in sense? Your flow will be leaving partially axial, partially in the radial direction. Those type of compressor we call it as the mixed flow compressor. As far as our aircraft gas turbine application concerned, we use either centrifugal compressor or axial flow compressor. So it depends on the application of our engine, for which type of engine. Based on the type of engine, we'll either go with the centrifugal compressor or axial flow compressor. Okay. Now, let's start with the axial flow compressor. So, how does an axial flow compressor operates, or how does an axial compressor is able to increase your pressure? Okay. If I say an axial flow compressor, I already told you your flow entry and exit, they will be in the axial direction, that is parallel to your shaft. Okay, so let's say this is my shaft, it is rotating, means your flow will enter in this direction and they will leave in this direction, axial direction. Okay, so if I take an axial flow compressor, I'll have two components. One is we call it as the rotor, another one is we call it as the stator. What is this rotor and what is this? The stator is that basically it is the row of blade. Okay, what is the rotor? Is basically it's a row of blade fixed along the circumference, which is going to rotate. There we are calling it as the rotor. And what is the stator? Is that it's basically once again row of blade fixed along the circumference or periphery of your shaft. Okay, which is basically immovable, or basically they are fixed. In sense, your stator blade will not move, whereas your rotor blade will rotate. Okay, so the one rotor and one stator combined together, we call it as the stage. What is a stage? Basically, it is the rotor followed by a stator. We call it as the stage in case of your compressor, whereas in case of your turbine, it is opposite. First, you will start with the stator, and then it will go to the rotor. Okay. So, we'll have in the axial flow compressor, we'll have the multiple stages, because that depends on the multiple stages or number of stages, depends on how much pressure you need to raise. Let's say in your aircraft gas turbines, we'll have a pressure ratio around 30 to 40, meaning is that, let's say if the inlet pressure of your air is 1 bar, means by the time it leaves the compressor, it will have 30, its pressure ratio is 30, means you will have the 30 bar. Okay, so depends on how much pressure ratio you required, we will go with that multiple number of stages. Okay, multi-staging is very, very common, or it is essential for axial flow compressor, because the pressure rise caused by a single stage is less. So we need to have a multiple number of stages if I want to increase my pressure to very high. Now, we know what is stage, we know what is rotor, and we know what is stator. So your rotor will be connected on the shaft, which is basically going to rotate, and your stator will be connected from the casing of your compressor valves. Okay, so your rotors are connected from your shaft, whereas your stator is connected from the casing of your compressor valves. Okay, so now this each rotor and stator has its unique function. Okay, so here comes the question: how I am able to increase the pressure of my fluid? Okay, So when the flow enters from your diffuser, okay, so when it is entering, it will have certain velocity. Okay, so when they are passing through this rotor, we are rotating our rotor. So the rotor is powered by the turbine. Okay, so when we rotate this rotor, what is happening? It is rotating at high velocity, right? So when the flow is moving over it, the momentum of your rotor will be transferred to your fluid. Just like you see your fan. How does it? What is happening in your fan? Yeah, it is sucking the air and it is blowing at a high velocity, right? Similarly, how? Because your fan is rotating at high velocity, so nearby air is having less momentum. So when they are hitting your blades of your fan, they are gaining momentum from your blade and they are moving with high velocity. Similarly, in case of your compressor also, as we will have the rotor, when the flow is passing over this rotor, its dynamic head will be increased. Basically, the velocity of your flow will be increased when they pass over your rotor. Okay, I told you, right? The difference between your fan and the compressor is that your fan increases the velocity, whereas your compressor increases the pressure. But here I'm telling my rotor is increasing the velocity. So that's why we have next component, which is basically stator. In the stator will have the row of blades, okay, which will act like a diffuser. Okay, diffuser instance, basically it's a diverging passage. When the flow, the high velocity flow is passing through this passage between your stator blades, its velocity, that is dynamic head, will be converted into pressure head. We have the Bernoulli's, right? P naught is equal to P plus of rho V square. From your Bernoulli's, you know your P naught is constant unless we have the external work added or external work extracted. So what we do in the compressor is that we add the external work input, that is we increase the half rho v square term, that is dynamic pressure of your flow. By increasing that, we are increasing the P naught. What is happening across your stator is that this dynamic pressure is converted into static pressure. So at the end of your stage, your flow will have a certain velocity and pressure. Okay, so which will be fed to the next stage. Okay, let's say if I don't have the stator, what is going to happen? Initially, let's say my flow is coming with 100 meter per second. My rotor is rotating at certain velocity, that is certain RPM. It is increasing my 100 meter per second to, let's say, 180 meter per second. It is increased, so that way you have increased your P. Now, if I don't have this stator, what will happen? This 180 meter per second flow will enter the next stage, means you won't have from 180 to let's say here 80 happen, means it will not become 260 meter per second, because both your rotor is connected to the same shaft, meaning that it is rotating at the same RPM. Already your flow from 100 to increasing to 180 is okay, but you won't be able to increase your 182 to 60. So if I want to add pressure, that is velocity to my flow, what I have to do is that once again, this 180 should be reduced to 100 meter per second. So that's what we do across your stator. Whatever the velocity is increased across your rotor will be once again decreased before it reaches the next stage. The decreased will be going to next stage. So when it goes to next stage, initially let's say 1 bar 100 meter per second, and when it goes to the next stage, let's say it will become 1.5 bar and 100 meter per second. Okay, even though it is having same velocity, but its pressure is small. So like that, slowly your pressure will be building up from one stage to another stage. Okay, so as long as I have the higher and higher stages, means I can get the higher amount of pressure rise across the axial flow compressor. Okay, that's what you see here. We have this rotor. This is a rotor component, and this is your stator, which is connecting from your very stationary vanes, which is connecting from your walls of your compressor casing. They are rotating. You see, when they pass through your rotor, what is happening? Your velocity is being increased. But when they are passing through your stator, whatever the velocity is increased, it is converted into pressure. As such, the pressure is slowly building up. But when it passing through your compressor rotor and stator, the pressure, sorry, your velocity is increasing, decreasing, increasing, decreasing. But when it is decreased, it is added to your pressure so that your pressure is slowly building up. By the time when it comes out of your compressor, it will have the high pressure and the less velocity, which will be fed to your combustion chamber. This is how an axial flow compressor is able to increase the pressure of your incoming flow. Okay, so with this, I'll end this to today's lecture. Okay, so what we have discussed, we have just started about what is a compressor or what is a turbo machinery and what is a compressor, what are the different types of compressor. Okay, and in that we have discussed about how an axial flow compressor is able to increase the pressure of your flow. Okay, so in the next class we will discuss about the velocity triangle and pressure rise across a single stage axial flow compressor. We are going to see what are the parameters which is going to like what are the dictating parameters by which your pressure ratio is depends on. We are going to see in the next lecture.
Like, share and subscribe. Hit the bell icon for more updates.